Let's get a little more practice at our function notation. So just a reminder, when we have a function notation, f, in this case, f of 7 equals 4, f is just simply the name of my function or the name of my rule or the name of the equation that I'm dealing with. Whatever is inside the parentheses is going to be my input, what I'm inputting into my function machine, and then what results is my output, what comes out as a result of the rule. So let's go ahead and just practice translating these basic function notations into coordinate points. So write the following as a coordinate point. Remember, x is my input, y is my output. F of -1 equals 1. Well, whatever is inside this parentheses is my input, is my x, and whatever comes out is my y. So this would be the point -1, 1. Here I have h of -2 equals 3, so whatever equation I'm dealing with is going to be called h. Whatever's inside my parentheses is my input, and whatever equals is my output. So this is going to be the point -2, 3. Go ahead and do the next two. Now let's go ahead and just practice some of the function notation stuff that we practiced so far. Here are different functions. So here's function f, g, h, and j. We usually don't use I as a naming of a function because it reminds us of a different thing in algebra. So let's go ahead and find g of 3. This means I'm plugging in 3 into my equation of g. So I'm going to use this one right here. So that's going to equal x squared plus 4. I'm plugging in 3 for x. So I get 3 squared plus 4. That's 9 plus 4, which is 13. So g of 3 equals 13. And then if I wanted to write it as a coordinate point, my input is 3, my output is 13. Go ahead and do the next few, and then when we get to the bottom 4, we'll get back together. You might have noticed in this example here, when we take the square root of anything, we have to take the positive and the negative, because positive 4 times positive 4 is 16, and negative 4 times negative 4 is 16, and that's actually going to give us 2 possible points. And this is because g is actually a parabola. So it's going to end up, this isn't the exact one, but it's going to end up looking similar to this. So you're going to end up having one point over here and then the symmetrical point over there. That's why we had 2 points with that one. All right, the next 4 is kind of a preview into some composition of functions. So let's see, this right here, 3 times f of 4. Well, my goodness sakes, what does that mean? That simply means I'm going to find f of 4. I'm going to plug 4 into my function of f, get an output, and then I'm going to multiply that by 3. So what does that look like? F of 4 is going to be negative 2 times 4 plus 3. Whatever that value is, I'm going to put that in brackets. So this is the value of f of 4, which I'll figure out, and then I'm going to multiply that value by 3. So here we have 3 times, negative 2 times 4 is negative 8. Negative 8 plus 3 is negative 5. 3 times negative 5 is negative 15. So 3 times the value of f of 4 is negative 15. This is going to be a similar one. So we're going to work with function j. I'm going to plug in negative 3 into function j, and I'm going to get a value as an output. And then I'm going to subtract 12 from that value. So let's go ahead and figure out what this value is, j of negative 3. Let's see, I'm going to put that in brackets. I'm going to plug in negative 3 into j, and I get 5 times negative 3 plus 6. So this is j of negative 3, and then I'm going to subtract 12 from that value. So now let's just go ahead and simplify this. 5 times negative 3 is negative 15. Negative 15 plus 6 is negative 9. So I have negative 9 and a negative 12, which is a negative 21. So j of negative 3, subtract 12 is negative 21. This one is a little bit interesting. I have f of 2 plus x. This is basically saying whatever my x value is, I'm going to plug it into f, but before I do that, I'm going to add 2 onto it. And then I'm going to go ahead and see what my answer is. Now notice, since we have x, we're plugging x in, our actual answer is going to have x in it as well. So what's going to happen is I'm going to replace x with 2 plus x. So I know that f of x is negative 2x plus 3. That's from my table up there. And I'm actually going to replace, anytime I see an x right here, I'm going to replace it with this 2 plus x, because that is my input. It seems a little weird, but that's my input. So I get f of, and again, this x is now 2 plus x, because this is my input, equals negative 2 times, what am I inputting? I'm inputting 2 plus x, and then plus that 3. And then I'm just going to simplify this. I'm going to distribute. And then I'm just going to simplify this as well. I'm going to put my x term in front. Negative 4 and a positive 3 is a negative 1. So notice my final answer with this one, I actually have x in my answer. This is actually the rule. If I would think of my function machine, this is actually going to describe the rule that happens when I take x and then I add 2 onto it. This is the rule that kind of comes out that makes that work. Now this one right here is interesting. This is f of j of x. Goodness sakes, what is going on here? I have 2 functions going on at the same time. This is really something called a composition of functions. And what's happening here is I'm starting with the function j, so in goes my input, into whatever rule j is, out comes an output, and then that output immediately gets plopped into my function f, and then it undergoes the rule, and then out comes an output. It's something called a composition of functions, and this is just a preview. So what happens is I'm going to figure out j of x, and I'm going to take that whole thing, and I'm going to plug it into f. So I know that f of x, I'm just going to write the equation here. F of x is negative 2x plus 3, and that's from my table. And j of x, I'm just going to write it over here just so I remind myself. J of x is 5x plus 6. I am going to take this value here, this 5x plus 6, and I'm going to plug it in for my input, and my input is x. So I'm going to replace x with this whole thing. So that equals -2 times, instead of x, I have this right here, 5x plus 6, and then my plus 3 over here. So here I inputted 5x plus 6 in for x, and now I'm just going to simplify. I get -10x minus 12 plus 3, and I get, I'll go over here, -10x, and then -12 and a positive 3 is -9. There we go. So -10x minus 9 is f of j of x. And notice I'm not plugging in a number, so I'm not going to get an actual number as a result. X is part of my input, therefore x is going to be part of my output. So this is called a composition of functions. When I plug in an input into j, out comes the output, it immediately gets plugged into f, out comes an output, and that rule can basically be summed up in a shortcut as -10x plus 9. If I plug in x in for here, and then I multiply it by -10, I subtract 9, that's describing the output that comes as a result of this composition of functions. So hopefully that was a nice preview of some of the functions that we'll see later on.